Subject name Industrial AC Machines. This third year subject. Subject code is 22523. And topic of the today's lecture is torque slip characteristics of three-phase induction motor. Myself, DP Sonone from Electrical Department. Now, as the topic of the today's lecture is torque slip characteristics of a three-phase induction motor, the torque slip characteristics is the curve which is plotted or obtained by plotting torque against slip from S is equal to 1, that is at the starting position, to the S is equal to 0 at a synchronous speed of the induction motor. That curve or that characteristics is known as the torque slip characteristics of an induction motor. As the induction motor is located from no load to full load, its speed decreases, hence slip increases. Due to the increased load, motor has to produce more torque to satisfy the load demand. The behavior of a motor can be easily judged by sketching curve obtained by plotting the torque produced against the slip of an induction motor. And this curve is known as the torque slip characteristics of a three-phase induction motor. We have seen that for a constant supply voltage E2 is also constant, so we can write the torque equation as now to judge the nature of the torque slip characteristics, and that is divided into the slip range of, that is, S is equal to 0 to S is equal to 1 into the two parts of analysis. Now as the torque equation becomes, torque is directly proportional to S into R2 divided by R2 square plus S square into X2 square. Now this is the torque slip characteristics of a three-phase induction motor. This is characteristic plotted between the torque and the slip. The torque is plotted over the y-axis and slip is plotted in the x-axis. Now the torque slip characteristics is plotted from at a starting position of an induction motor to the starting speed, that means n is equal to 0 to the synchronous speed of the induction motor. And this curve is known as the torque slip characteristics of a three-phase induction motor. Now at the speed n is equal to ns, means when a rotor of the induction motor is rotating at the synchronous speed, at this time s is equal to 0, means in this condition torque and slip increases linearly with each other. So the point O to A, this is the stable region or a low slip region, and the point A is the maximum torque condition, that is the slip S is equal to Sm, that is S is equal to R2 divided by X2. It is the condition of slip at which we get the maximum torque. Now from A to B is the region in which the motor is operated in a stable region. This is the unstable region, that is point A to B. And now B is the starting torque of the induction motor at which S is equal to 1 and N is equal to 0, means in this condition there is no speed over the induction motor means the rotor of the induction motor is remain at the standstill condition. This is the torque slip characteristic of three phase induction motor. We have seen that for the constant supply voltage E2 is also constant, so we can write the torque equation as now. To judge the nature of the torque slip characteristics, let us divided the slip range S is equal to 0 to S is equal to 1 into two parts and analyze them independently, as torque is directly proportional to SR2 divided by R2 square plus SX2 whole square. Now the first region is a low slip region in which the S is very small. That's why the term S square into X2 square will be neglected as compared to the term R2 square. So in the low slip region, torque is directly proportional to the slip. So as the torque increases, therefore slip also increases, and that's why this in this region torque and slip increases linearly with respect to each other. So this region is known as the low slip region or a stable region. Hence the graph is hence the graph is in a straight line in nature at n is equal to ns, means at this condition rotor is rotating at the synchronous speed, so therefore s is equal to 0. Therefore there is no any torque is produced. As no torque is generated at n is equal to ns, motor stops. If it is tried to achieve at a synchronous speed, torque increases linearly into this region at the low slip value. Now in case of high slip region, in this region slip is high, that is slip value is approaching to 1. Here it can be assumed that the term R2 is very small as compared to the S square into X2 square, therefore neglecting from the denominator. So the term of the torque will becomes S into R2 divided by S square into X2 square. So the torque equation becomes, that is here torque is inversely proportional to the slip, because R2 and X2 are constants. So in a high slip region, torque is inversely proportional to the slip. So in this region, at the time of at the point B, at the point maximum slip, that is R2 divided by X2. After that point the curve becomes in a rectangular hyperbola type, because the slip is approaching to the 1 and the slip is inversely proportional to the torque, because when slip is increasing, at that time torque will be decreases. Now when the load increases, load demand increases, but the speed decreases. As the speed decreases, slip increases. In a high slip region, as we know that the torque is inversely proportional to the inversely proportional to the slip, torque decreases, slip increases. But the torque must be increases to satisfy the load demand. As the torque decreases due to the extra loading effect, speed further decreases and slip further increases. Again torque decreases as the torque is inversely proportional to slip. Hence, same load acts as the extra load due to the reduction in torque produced. Hence, speed further drops. Eventually, motor comes to a standstill condition. The motor cannot be continue rotate at any point in this high slip region. Hence, this region is known as the unstable region of the operation. So, the torque slip characteristics has two parts, that is the straight line, also called as the stable region or a low slip region, that is point from O to A, that is OA, and the rectangular hyperbola is called as the unstable region. In this region, the slip is approaching to the 1 0 to above 0 to 1. So this region is also called as the unstable region or a high slip region. Now this is the uh, at, at the s is equal to 1, n is equal to 0, that is at the starting position, motor produce a torque called as the starting torque, denote as the TST. The entire torque slip characteristics is shown in this figure. Now here is the full load torque at the point C. When the load on the motor increases, the torque produced increases as the speed decreases and the slip increases. The increases torque demand is satisfied by drawn motor current from the supply. The safe limit of the current is that which when drawn from the continuous operation of the motor. Motor produces the temperature rise well within the limits. Such a full load point is shown on the torque slip characteristics of the torque as the TFL, as shown in the last slide. In that figure, there is the point C, at which the motor operated on the full load torque. That's why the full load torque is less than Tm. Now here is the generating and the braking region of the induction machine. That point is known as the point O. When slip lies in the region 0 to 1, that is when slip is operated in between 0 is less than equal to S is less than equal to 1, the machine run as a motor, which is a normal operation. When slip is greater than 1, the machine works in a braking mode. Means when the sleep of the machine is greater than 1, that at that time the machine works as the braking mode. To run the induction motor as a generator, the sleep must be less than 0. That means the sleep should be a negative. At this condition, the induction machine is rotated in a generating mode. The negative slip indicate the rotor is running at the speed above the synchronous speed. When running as a generator, it takes mechanical energy and supplies electrical energy from the stator. Thus, the negative slip generation action takes place, and the nature of the torque slip characteristics is the reverses in this region. Means, in case of motoring action, the torque slip characteristic is a reverse that of the generating. Now here is the complete torque slip characteristics of a induction machine which is operated in a braking region, motoring region and a generating region. In this slide, the below figure is shown the complete characteristics, torque slip characteristics showing the motoring, generating and a braking region. Now in a braking region, the slip is more than 1. That means the induction machine is operating in a braking region. In case of a motoring region, the slip is less than 1. In this region, the induction machine is operating in a motor or a stable region. And now in a generating region, the condition for the slip is the slip should be a negative, and in this slip the machine or induction machine is operating in a generating region. These are different slips in which are operating in a different region. Thank you.